Hi guys, Mr. Hescox here. This is a whole packet of practice for Chapter 6 on atoms, and it's going to lead us into making compounds. But before we do compounds, we've got to review valence electrons and structure of atoms so that we can work through this. So I'm putting this little video together to kind of give you some help. So counting atoms. This should look familiar to you. We did this before, but I want to review real quick. So C is carbon. In this case, 9. H is hydrogen. 8 and O is oxygen. 4. Something like that. So if we go down, you guys are going to work through most of these. I'm going to do a harder one with you. I think we'll do this one here called calcium dihydrogen phosphate, which in this case is alright, so Ca is calcium. And it is on the outside. Now when you do these, you have to distribute like in math class, but you distribute backwards. So that's calcium 1. So hydrogen 2, but you multiply that times 2, so that becomes hydrogen 4. One phosphorus, but that 1 is times 2, so it becomes phosphorus 2. And then you have 4 oxygens, but that's times 2, so that becomes oxygen 8. And that's how you'll do that section right there. So there's 2 pages of practice here. Make sure when you do this one that you add all of the oxygens together. Alright, so drawing atoms. Now we did this one before, but I want to stress the structure of these atoms. And I'll tell you why. If you don't understand how the valence electrons work, it is impossible to go further. So I'm intentionally redoing this as kind of a practice. There's only 5, and we'll do them, a couple of them here together. So let's do neon. So in this case, neon has atomic number of 10, which means 10 protons. So neon, in here we're going to put 10 protons. Number of neutrons, 10 neutrons. Positive, negative. Now I'm making this a little bit bigger. So the first electron shell only holds 2. 2. How many in the second? Well, you need to get to 10, so you need 8 more. 1, 2, 3, 4, 5, 6, 7, 8. Well, I jumped to a different screen here. This is an interactive periodic table. When you want to know how many valence electrons are in any shell, The group tells you the valence electron. So this one has 1, these have 2, boron group has 3, 4, 15 has 5, 6, 7, and then 8 in their valence shell. If you want to know how many electrons go into it, so 1 electron is 1 shell. This opening shell only holds 2 electrons. The second shell holds 8 electrons. 8 electrons. If you would make it all the way down to here, you actually get 18, 18, and if you go crazy all the way down here where you get your lanthanoid and actinoid series, it now jumps up into 32. But for our purposes, we're going to kind of focus in these atoms up here and these atoms over here. So let's do fluorine together. Fluorine is F, 9 on the periodic table, 10 neutrons. So there's our nucleus. I need 9 protons, 10 neutrons. It has 9 total electrons because you have 9 positive, you better have 9 negatives. I can put 2 electrons in my first shell. 9 minus 2 is 7. I need 7 in the next shell. 1, 2, 3, 4, 5, 6, and 7. Now what's interesting about fluorine, fluorine would love to have 8. If it has 7, wants to get to 8, it needs to gain. And that's where we're going next. So here's some more where you're going to draw your protons in, protons, neutrons, and then draw in all of the electrons. These are some bigger ones, but they're already set up for you. You can treat this as the nucleus. Sometimes you will have to draw in some extra. So these will look a lot like this. So atomic number is 16, so it's 16 protons, 16 electrons. You got 2, then you go 8 in this shell. 2, 3, 4, 5, 6, 7, 8. Well, 2 plus 8 is 10. I need 16. You have to draw another shell and put 6. 6. Okay, this would like 8. It has 6. Wants to get to 8. What do? You would gain 2 electrons. If I have 18 negative charges and 16 positive charges, what's the charge of that ion going to be? Well, this is just like math class. I've got 18 negatives, 16 positives. It's going to be negative 2. An ion of sulfur will end up being sulfur with a negative 2 charge. So here's where I want you to draw these out so we can get ready to figure out our ions, because you can't do ions without understanding where that goes. This is talking about valence electrons and bonding. The only electrons that are used in chemical bonding are the valence electrons. That's the outermost shell. So let's jump ahead here. Predict whether each of the following will gain or lose or fail to react. So you have to count the outer shell. 1, 2, 3, 5, 6, 7, 8. So this is actually a picture of neon. It has 8. 8 is full. If it's full, it doesn't want to eat anymore. This one would be fail to react. sloppy. If we jump to this one, you have 1, 2 in the first shell. That one's full. 1, 2, 3, 4, 5, 6, 7. So this is 7. It wants to get to 8. Well, you have to gain. So this one's going to gain electrons. Now you can see why we were doing the page before. It's going to have to gain a 1 electron because it really wants one more electron right in here to fill it up. When it gains an electron, it becomes negative. All right, so here's one here. 1, 2, only 1 in the outer shell. So this is the question you have to ask yourself. Is it easier to gain 7 electrons or lose 1? Well, it's much faster to lose 1. So this one's going to just lose that 1 electron. General rule of thumb, it will lose electrons if it's 1, 2, or 3. 4 is that magic number where it can gain 4 or lose 4. If it has 6, 7, or 5, 6, or 7, it's going to gain 1, 2, or 3. It will just lose those electrons. If you lose an electron, this is no longer here. This will now be positive. All right, so here's our last page. And like I said, you'll have plenty of time to work on this in class. If you have 3 valence electrons, well, that's that 1, 2, or 3. We lose 3. When you lose 3 electrons, so they're 3 and they're already negative because they're electrons. If I take 3 of them away, right, a negative negative makes a positive. So the charge of this one will be positive 3. Chlorine wants to gain an electron because it wants to get to 8. So if you gain an electron, so if you have a charge of 0, I add a negative 1 to it. My charge becomes negative 1. To write your formula, I have 3 positives, only 1 negative. So in other words, it takes 3 chlorines to balance out my aluminum with 3 positives. So it becomes AlCl3. I'm not even going to try and write that in there. The 3 negative 1s equal that. If you have trouble with the formulas, I'll try and get back to you guys to help you, but let's try like one more here. Let's try this calcium. So calcium has 2 electrons. It loses those 2 electrons, becomes positive 2. Phosphorus has 5. It wants to gain 3, so it becomes negative 3. So what's the number that 3 and 2 go into? Happens to be 6. So I take my calcium times 3 would give me 6, so it becomes calcium 3. I have minus 3 here. I got to take that times 2. Phosphorus is P times 2. My pen's not working very good. And that goes right there. All right, ladies and gentlemen, I hope this helps. This will take a couple days, but we'll get over it. Catch you later. I'm Mr. Hescox.